This video will start our next unit, which will encompass the next 5 weeks of the semester, in which we'll cover the basics of deductive logic. We'll start with the truth functional connectives, which we'll introduce over the course of the next 4 videos, and those will be the core of the logical system we use to construct complex statements and later in evaluating arguments. We'll start by introducing the notion of an atomic statement, and then introduce our first logical connective, negation. That will help us build up more complex sentences from those atomic ones. And our aim will be to start to translate English sentences into statements of logic, starting with this symbol for negation. The text calls the system we're going to introduce now truth functional logic, or TFL, because it introduces truth functional connectives. We'll talk more precisely later on about what truth functionality really means. Note that the system we're going to look at is also commonly called propositional logic, and I think this might be a clearer name for now. It's called that because the most basic units of the logic are symbols for statements or propositions. And if you look at the text, there is some discussion in our first reading of the relation between statements and propositions. The aim of truth functional logic is to give us a system for symbolizing statements and arguments, and that allows us to express and identify certain arguments which are valid in virtue of their form. So this idea should be familiar from our introduction to logic. It is important to note that some arguments aren't formally valid, but nevertheless are valid because they satisfy the definition that if the premises are true, the conclusion has to be true. The difference with non-formal validity is that an argument with the same form but different content may not be valid. So the argument, the house is square, so the house is rectangular. If that is true that the house is square, the house has to be rectangular. But we couldn't substitute other terms in this example. So you couldn't reason, for example, from the house is square to the house is green. That argument has the same form, but isn't valid. Truth functional logic is not intended to capture non-formal validity. Its purpose is to capture the relations between statements that occur in virtue of their form. So form is our focus now. And since we need to represent the form of statements, we're going to need some tools for abstracting away from their specific content. So sentence letters will be our first tool for doing so. We use single statement letters, single uppercase italicized letters, to represent atomic statements. Atomic statements are the simple statements that serve as the most basic elements from which we build up complex statements and arguments. What the atomic statements are will become clear once we begin to introduce our connectives. When we introduce statement letters to represent simple sentences of English, we must include a symbolization key, which is also often called a dictionary, that associates our sentence letters with a corresponding statement of English. So here's a kind of symbolization key that tells us what the sentence letters stand for. So uppercase italicized letter D is going to stand for dogs bark. The uppercase italicized letter N can stand for New Jersey is a state. Both of these are atomic statements, symbolized with sentence letters. Once we have sentence letters as our basic elements, then we can build up more complex statements using 4 key logical connectives. The first truth functional connective we're going to look at is negation. It's symbolized with this symbol that we'll call not, so that bar with the tail. And we use it in front of a simple sentence letter to create a new complex sentence. So this symbol not is used to express the meaning of the word not in English, or a phrase like it is not the case that. So we use this symbol to represent sentences like it's not the case that Tegucigalpa is in Peru, Vern can't play the trombone, and also in less obvious denials like the work she did is unacceptable, or that noise is intolerable. So we can symbolize those examples on the previous page as follows. We identify the part that's the positive simple statement and excise the negation so that we add the negation to the simple atomic statement. So we take Tegucigalpa is in Peru as our simple atomic statement, and the negation of that gives us the meaning. It is not the case that Tegucigalpa is in Peru. So we get not P as the logical representation of it is not the case that Tegucigalpa is in Peru. Similarly, we can represent Vern can't play the trombone as the negation of V. Vern can play the trombone. So that gives us not V as our logical statement representing Vern can't play the trombone. Both of those examples included the word not specifically. The nt at the end of can't is just shortened not. But we can also include negation in ways that don't use that word. So the work she did is unacceptable. That's the negation of the English sentence, the work she did is acceptable. So not W accurately captures the original English meaning. It's not the case that the work she did is acceptable. So again, the symbol you can think of as a short form of it's not the case that, and then our atomic sentence letter represents the positive meaning of the statement. And finally, that noise is intolerable can be represented as the negation of T, that noise is tolerable. So we get not T as our symbolization. As we saw in the last two examples, some statements that should be translated using logical negation don't involve the word not. And all the words below are more examples of negations that don't use the word not explicitly. No one arrived on time, nobody left early, nothing was left behind, none of the guests stayed late, the invitation was nowhere I could find it, we never found the invitation. Our job in looking at these sentences is to figure out what is the sentence that they're a negation of. So a challenge with these terms is it's often tricky to determine what the positive statement being negated is, or the simple atomic statement being negated is. So look at the statement above. No one arrived on time. Is that a negation of everyone arrived on time or someone arrived on time? Take a moment, consider which one needs to be negated to capture the meaning of no one arrived on time. So the statement someone arrived on time is the one that needs to be negated. It's not the case that someone arrived on time. Captures the meaning of no one arrived on time. So our atomic statement should be T, someone arrived on time, and our negation should be not T. Note that you can use any statement letter to represent any atomic statement. I often find that it's kind of helpful to pick ones that are mnemonic in some way. So in this case, I picked T because time seemed to be the main issue in this one. But you don't have to do that. You can start with the beginning of the alphabet if you want. Let's look at a few more of these examples that use negative quantifier terms. As we go down the list, pay attention to the positive statement, the atomic statement, that gets negated to give the meaning of the original statement. Nobody left early is the negation of the atomic statement, somebody left early. So if that atomic statement is given the sentence letter L, we get not L as our symbolization of nobody left early. Nothing was left behind is the negation of something was left behind. So it's not the case that something was left behind. None of the guests stayed late is the negation of some of the guests stayed late. And the invitation was nowhere I could find it is the negation of the invitation was somewhere I could find it. For each of the negative quantifier expressions on the left, we can see on the right what we have to apply negation to get an accurate negation of an atomic statement. So no one is not plus someone. Nobody is not plus somebody. Nothing is the negation of a sentence with something. None is the negation of a sentence with some. Nowhere is not somewhere. Never is not ever. So if you have some not, if you want to take the negation of that, you have to get it's not the case that all, etc. And something is not needs to be represented as it's not the case that everything is some way. Be super careful when translating from English to logical negation and logical notation in general that you always have to consider whether your symbolization accurately captures the intended meaning of the statement. And often, correctly symbolizing logical negation will require careful thought about what exactly the negation is applied to and what, if anything, is the true contradiction of that sentence. So sometimes statements containing words that can sometimes function as negations aren't best captured with negation. So the statement, John is particularly incompetent at fixing cars, for example. That word incompetent has the prefix in. We've already seen that that can sometimes be represented with the negation. But does this statement really mean it's not the case that John is particularly competent at fixing cars? No, that's too weak to capture the meaning of this statement. If you say John is particularly incompetent at fixing cars, that means that John is bad at fixing cars. So we shouldn't translate this as a negation. We should just translate it as a single statement. John is particularly incompetent at fixing cars. That should be an atomic statement with no negation. And in our next lesson, and some of the ones following, we will look at some additional complexities that arise when negation interacts with some of our other logical connectives, including conjunction, which we'll look at in the next video.